Hello everyone, welcome to my YouTube channel Fun with Maths. I'm Shalja Tripathi and today we are going to solve this question on quadratic polynomial. So let's begin. So we are given polynomial fx is equal to x square minus px plus q. So we already know the general form of quadratic equation. General form is x square minus sum of the zeros plus product of the zeros. So this can be written as x square minus alpha plus beta x plus alpha beta. So on comparing both the equation, we find that alpha plus beta is equal to p and alpha beta is equal to q. So this is the piece of information that we are going to use to prove the above relationship. Now on solving the LHS of the given question, that is this part. So let's write down LHS. See, solving LHS. So our LHS is alpha square upon beta square plus beta square upon alpha square. So we will solve this. So the first thing to do is take the LCM. So let's take the LCM. We get alpha square plus beta square. Sorry. Here we write alpha square beta square. So here we get alpha raised to the power 4 plus beta raised to the power 4. Now how to solve this? First we are going to understand the identity that will be used. See, we already know this identity. A plus B whole square is equal to A square plus B square plus twice AB. So we are going to rearrange this identity. On rearranging, what we get, A square plus B square, or let me write down this way. A plus B whole square minus 2AB is equal to A square plus B square. Now if in place of A and B we have A square and in place of B we have B square. So this identity is again written as square of the first term plus square of the second term plus twice A square plus B square. See, if we rearrange this, what we get, A square plus B square whole square minus twice A square B square. This is equal to A raised to the power 4 plus B raised to the power 4. So first we'll be using this relationship. So in place of alpha raised to the power 4 and beta raised to the power 4, we'll rearrange it in this form. See, it can be arranged as alpha square plus beta square. So we are using this part minus twice alpha square beta square upon alpha square beta square. See, from above relationship, we already know that alpha product of the zeros, that is alpha beta, is equal to q. This we found out earlier here in this part. So replace alpha beta with q. So what we can do is, see, alpha square plus beta square whole square minus 2q square upon q square. See, in the next part, we'll again open this identity, this part, using the formula a plus b whole square. Okay, now let's write down. See, this can be understood with this equation or this identity. So it can be written as a plus b, that is alpha plus beta whole square, minus twice alpha beta raised to the power 2 minus 2q square divided by q square. So in place of this, we are replacing it with this using the identity. Now we already know alpha plus beta is equal to p. So replace alpha plus beta with p. Let's see what we get. We get p square minus twice alpha beta is q whole raised to the power 2 minus 2q square upon q square. Again, using the identity, will open the bracket or expand this bracket. What we get, square of the first term plus square of the second term minus 2 times the product of first term and second term minus 2q whole divided by q square. So we have p raised to the power 4 plus 4q square, and here we have minus 2q square. So let's write it down here. Minus 4p square q whole divided by q square. Now divide each term by q square. Let's see what we get. Or let's solve this part first. So here we get plus 2q square minus 4p square q whole divided by q square. Now divide each term by q square. So we get p raised to the power 4 upon q square plus, here we get 2 minus 4p p square q, or let's rearrange. We get minus 4p square q, sorry, p square q, no, we will get here p square upon q, because on dividing this q will get cancelled with this one. So we have this plus 2, and this is our RHS. Hope you understood the solution well. Please like, share and subscribe, and thank you so much for your time.